Can you all hear me at the back? Okay. Do we have people who watch movies here? Specifically action movies. If you do, please raise your hand. Action movies. We have few people. I guess the rest watch maybe romantic movies. Okay. So the reason why I am asking you if you watch movies or not is that these movies have one thing in common. And that thing is that we have the main character of the movie, or the steering of the movie, with his enemies tracing his whereabouts and his daily routine, trying to kill him, of course, for some reason. And when they fail to do that, they go after something that is very close to his heart. It can be his wife or his child. What I need you to keep in mind is something that is very close to his heart, because I am going to talk about something that is very close to the two-spotted stingbug. So this is the pest that has been and still is causing damage to the macadamia nuts. And the good thing maybe about this pest is that it has long been identified, and we know exactly when we find it in the macadamia orchards, and it is still controlled by the chemicals, which are not very environmental friendly. So this pest is attracted by the nuts in the macadamia orchards. So other than being attracted by the macadamia nuts in the orchards, what is the driving force of this pest? So for this pest to be able to feed, to move around your orchards like they own them, they mate, and they even produce, it means that the environmental conditions in your farm are favorable to such a point that all these things can happen. So the temperature is the second driving force of the two-spotted stingbug after the availability of macadamia nuts in your orchards. So this is where we are standing right now. We have the two-spotted stingbug that you scout and you spray, you scout and you spray. So let us try to think about this problem like this now. We have the two-spotted stingbug here that depends on temperature. And the question, or the most important thing that we should ask, is that what do we know about the two-spotted stingbug and temperature? The temperature that I'm talking about is changing, it's daily changing. We are all witnessing that. I'm not going to say much about the current weather events that are happening now, because we are all seeing that, the heat waves and the cold snaps. So if the temperature is changing, it means that even the development of the two-spotted stingbug is going to change, or everything that has to do with the two-spotted stingbug in the orchard is going to change due to the temperature that is changing. So this means that if the temperature change is going to alter the development of the two-spotted stingbug, it means that even the alternative strategies that can be developed to try to control the two-spotted stingbug will also be affected. So talking about extreme weather events that are being altered by the climate change, this study was published last year, and it showed that extreme heat reduces the use of chemicals in the field. And the temperature that was referred to here, it was 34 degrees Celsius. This was in Switzerland. But the difference is that in South Africa, we experience temperatures that are way above 34 degrees Celsius. This goes back, what I need to highlight about this paper or about this study is that this goes back to ask the question that, what is it that we know about the two-spotted stingbug and temperature? Do we have anything on the table? Do we have any data on the thermal tolerance of the two-spotted stingbug, or we just spray it to get rid of it? So first, I would like to explain what really happens when the temperature increases to insects. So I'm going to give an example of the two different life stages of the two-spotted stingbug that get knocked down, let's say by a heat wave of 43 degrees Celsius or a cold snap of -5 degrees Celsius. So what happens is that for this pest to be able to cope, they go through a process called hardening. So this process, it allows this pest to cope during that specific period of time. So when they keep on experiencing these temperatures, that's when they get acclimated. And once they get acclimated, they are going to be temperature resistant. They will even be able to tolerate temperatures that are way above what they are experiencing now, if they are able to acclimate. So trying to understand the thermal biology of the two-spotted stingbug, or trying to get or to understand the relationship between the two, we went to Mr. Fritz Arendt's farm. Is he around? Is he around? No, he's not. He's the most welcoming person I've ever met in my life. So Mr. Fritz Arendt's, Mr. Fritz Arendt's, we collected eggs and the different life stages of the two-spotted stinkbug, and we established a colony in 2020. And the good thing about this colony is that it is still running, it is still up and running at the University of Venda. We still have this colony that was established in 2020. So the first thing that we did, or the first question that we asked was, can we detect hardening in the different life stages of the two-spotted stinkbug? And the temperature that we used for heat hardening. For everything that we did, we were looking at the response of the two-spotted stinkbug at high temperature and low temperature. So for the high temperature, it was 41 degrees Celsius for 2 hours. And we find that all the life stages of the two-spotted stinkbug can actually survive this temperature. But Insta2 and Insta4 were the only two life stages that responded better than the rest. And moving down to cold hardening, for -8, all the stages of two-spotted stinkbug survived a temperature of -8 for 2 hours. And these are the life stages that performed better than the rest at -8 degrees Celsius. Now, moving down to acclimation, as I said, acclimation occurs in days to weeks. So we did this for 48 hours. So what happens with acclimation is that if we acclimate at a temperature of 20 degrees Celsius, we expect the critical temperature to increase because it has been said in the literature that acclimation improves the tolerance of an insect. So our results showed us that Insta2, again, was the only stage that responded to different acclimation temperatures. Even the other stages did, but this is the only stage that responded to all the acclimation temperatures. Now, moving down to low critical temperature, the females are the ones that responded to acclimation temperature with a low critical temperature of 0.8 at 20 degrees Celsius and 3.1 at 30 degrees Celsius. So now what we did was that we were trying to link the results that we find in the lab and the temperatures in Mr. Fritz Arendt's. So these are the temperatures in the laboratory and in the orchard. So for high temperature, the highest temperature that was recorded in Mr. Fritz Arendt's using the weather station data, it was 41.9 degrees Celsius. And the high temperature range for all the stages were above this temperature that was recorded in the field because it was 44.4 to 46.5 degrees Celsius. And for low temperature, it was 1.1, and then in the lab, it was 0.6 to 4.1 degrees Celsius. So we went on and asked that how does temperature affect the development of the two-spotted stinkbug, and that is from egg stage to adult stage. So at 20 degrees Celsius, we found that it takes the two-spotted stinkbug 72 days to fully develop from egg to adult, and then the development time decreases with temperature, where it was 37 days at 30 degrees Celsius. So from that data, we calculated the lower developmental threshold and cumulative degree days. So this lower developmental threshold is used to calculate the degree days. So these are the lower developmental threshold of the two-spotted stinkbug for all the stages and cumulative degree days. So the lower developmental threshold is the temperature where development starts. This is where the development of the two-spotted stinkbug starts. So for the eggs, it was 12 degrees Celsius, and then for the rest of the stages, it was 15 degrees Celsius. And then the cumulative degree days started from 72 to 442 with the 5th instance. And now, we also determined the optimum temperatures. And the reason why I included this is that we have people who are rearing insects, who are rearing the two-spotted stinkbug. So the optimum temperature that was found here for the eggs, it was 30 degrees Celsius, and then 27 for Insta1 up to Insta3, and then 26 degrees Celsius for Insta4 and Insta5. And then we went on again and asked, how long does the female, since they are the ones who are laying eggs in your orchards, we asked how long do they live for? How long do the adults live for? So at 20 degrees Celsius, we found out that they live for 40 days. The adults, females, live for 40 days, and then 25, 30, and then 29 degrees Celsius, 18. And then at those two temperatures, I'm not going to say much about those two temperatures because we still have females that are living and that are still laying eggs as I'm standing right now. So, again, we wanted to know how many eggs does one female on average lay eggs? And then what time does it take for one female to start laying eggs at different temperatures? So at 20 degrees Celsius, it took them 20 days to start laying eggs with 54 eggs on average. And then 25, it was 14 days with 102 eggs on average. And then 30 degrees Celsius, it took them only 10 days to start laying eggs. Meaning that if the temperature is high, it means that they're going to start laying eggs quicker or faster than when the temperature is lower in your orchard. So now, this is the bigger picture or the whole point of this project, to build a phenology model. So what happens here is that everything that I was just talking about now, we incorporate everything to build a model that predicts when the two-spotted stingbug will be stressed in your orchards and how many generations are you going to have during that season, and then when are you going to start having eggs in your orchard. That is the whole point of doing all this work that I just presented to you. The whole point is to build a phenology model. So we went back again to Mr. Fritz Arendt's, that's the farm that we started with. So these two plots are showing the time that the two-spotted stingbug will be stressed, and according to the model that we did, there will be 2 generations in his farm, in Mr. Fritz Arendt's farm. Unfortunately, he's not here. I will send this to him. And then on the second one, we also did this for the Bavenda farm. And then this is the days that the two-spotted stingbug will be stressed, and then they will have 3 generations. So those on the second plot, those steps that you see are representing the generations. And on the bottom there, that is the egg stage, and then Insta1, Insta2, Insta3, until they go up to the adult stage. And up there, that's where they are laying eggs, and then they go down again to start off with the Insta1s. And then we did this again for the Abba orchard, and then this is what we find. There's stress, and then here it's going to be 2 generations and half of a generation. So the highlights of my study are that temperature is increasing in the face of climate change, and the critical limits that we found in the lab are way beyond what they experience right now in the field. And there's a proof of thermal hardening when exposed to extreme short temperature and acclimation over longer periods. So this means that the two-spotted stingbug is here to stay, and it is still going to cause damage on your macadamia nuts based on what we found. So, to all macadamia farmers, everything changes with time. So are the climatic conditions. How prepared are you for these changes in terms of managing the two-spotted stingbug? I thank you.
Guys, questions for Mulalo? Mulalo, it looks like you're getting off easy, but I'm good. Oh, there's one.
No, there's a question.
There's a question.
Great. That's an interesting talk, and we're looking forward to more work being done. Have you done any work on humidity and the effect on stink bug?
What, humidity?
Yes, air moisture, humidity.
Yeah, that's actually a very good question. So the reason why I said that I'm going to exclude those 2 temperatures that I said that they are still too there are still females that are laying eggs is that I did these experiments for the first time, and then I was not controlling humidity. And the second time now, I'm repeating these experiments. For the second time, I was trying to control humidity, and I found out that at 2 different temperatures, 25 degrees Celsius, I have 25 degrees Celsius, that has an average humidity of 65 degrees Celsius, and another 25 with a relative humidity of 25 to 24 degrees Celsius, and there's a huge difference between the two. So a lower humidity, it seems to perform better than the higher humidity.
Another question?
I assume you've used fixed temperatures in your lab work.
I beg your pardon?
Fixed diurnal temperature.
Fixed, you mean like constant temperatures? Yes, we are using constant temperatures, and that was actually my problem in 2015 when I started my honors. So I used to ask myself, why are we using constant temperatures? Because in the field, they are not exposed to constant temperatures. So the reality here is that what matters is the amount of heat units. So maybe I did not explain that when I was explaining the cumulative degree days. What matters is the amount of heat that is required for each stage for an egg stage to develop from egg to instar-1, from instar-1 to instar-2. So some studies now, as I'm speaking, they have started using fluctuating temperatures, not constant. But where I am right now, we cannot do that. We cannot use those temperatures. We are using constant temperatures. But the good thing about constant temperatures is that what we are finding in the lab, sometimes you will realize that the development in the lab is also the same as what is happening in the field. So what matters is the amount of total heat required for an egg stage to develop to instar-1.
Mulalo, maybe just a comment from the side. We've done 4-year study down at Nelspruit at the ARC. And the work we did there basically confirms what you have found in the lab. In the field, for 4 years in a row, we found basically 3 cycles going through, which really confirms what you found. So I think that's quite important. Yeah,
it is. And then it depends on the location of the orchard, because if, let's say we have orchard 1, orchard 2, and orchard 3 at an elevational gradient. So the first orchard might have 3 generation, and the second one might have 2, and then the last one might not even have any generation because the temperatures are not going to be favorable. So it all depends on the location of the orchard and the temperature. That's why I said that I'm going to talk about something that is very close to the two-spotted stingbug. The weather station's data or the temperature is the most critical thing when we talk about pests. Each and every single, as long as it's an insect, it depends on temperature, and we cannot talk about anything without talking about temperature if we're talking about insects. So it depends. Yeah, you are correct, but it also depends on the location of the orchard.
We have to move on with other thanks.